Hi everyone, welcome to Lesson 13, Sensitivity and Risk Analysis. Actually today we're going to get started with risk analysis first, and we'll flow into sensitivity analysis. Here's where we are in our course progression. We have one more lesson after this in decision making, that is trade space analysis, and then we'll move into the solution implementation phase. Here are the 4 lesson objectives that we'll cover today. First, apply the 3 risk management activities in a system lifecycle. Define the 4 types of risk exhibited in the system lifecycle, understand sensitivity analysis, and then perform and interpret sensitivity analysis. So here are the 3 risk management activities. The first one being identifying the risk, second one assessing the risk, and the last one managing the risk appropriately. This cartoon is kind of funny, but it shows these 2 hikers that are on a walk around some cliff, and they see a rock up there, the rock being the risk. They identify that rock as possibly causing them harm. They do some assessment in deciding what to do about the rock as it's falling, and then they manage it by running away. So we're going to do the same thing today, except in a less simplified version of it. The first step is in risk identification. As I mentioned, the definition of risk is a probabilistic event that, if it occurs, will cause unwanted change in the cost, schedule, or value return of an engineering system. And we have 4 types of risk in our risk identification phase, and here they are. The first one being technical risk. Now, technical risk is possibility that some requirement in a system will not be achieved. You could think about implementing a new system. Say the Army wants to implement a new rifle system for the rifle squad of the future, or a new weapon system for the rifle squad of the future, and it sends out a list of requirements that that weapon system must achieve. A contractor takes the program, takes the contract on. There is some risk at play. The contractor signs an agreement saying that they will provide such capabilities as such technical requirements in order to accomplish the needs of the stakeholders in this weapon system, but a risk might be that they're unable to actually meet those requirements that they agreed to do. So that's the definition of a technical risk. Cost risk, cost, and we think not just monetary cost, but we think resource cost, or constraints, or I guess resource and time would be another resource that we have that we could consider in cost. The possibility that a project will exceed what's budgeted for it. So using the rifle squad of the future example again in this weapon system, perhaps we budgeted a set number of time for research and development, and it takes longer, with thus delaying the entire process, and that kind of bleeds into schedule risk. But also for cost, maybe research and development costs a little bit more money than we budgeted, so we are now in the hole a little bit as far as our project budgeting is concerned. Schedule risk, possibility that the project will fail to achieve key milestones. So if we don't meet the time hacks that are required, and we do not roll out this weapon system in time, then that would be a schedule risk. And then of course there are things like programmatic risk, or environmental factors, or programmatic risks that are outside of our control, but that are still should be considered. One example for this weapon system is perhaps some new enemy threat arises that the weapon system now needs to achieve or defeat, and we weren't planning on having that new enemy threat, so it's a programmatic risk. Or maybe something like COVID strikes, and we don't have the resources available to plan, to do research and development, to prototype in the new environment. So that could be a programmatic risk, something that is really outside of our control in the larger environment. So once we've identified the risk and we know what kind of risk it is, we can move ahead to risk assessment. And this is categorizing the likelihood and consequence of this risk actually occurring. The chart that you see there is the risk assessment matrix that comes from the Army's composite risk management. If you're in charge of planning a range, or if you're an investigative officer for a safety incident, you'll likely see these different categories in the Army of incidents or of risk. And basically it takes the probability and the severity ranging from catastrophic to negligible, the probability ranging from frequent to unlikely, and it finds the type of risk, or the the assessment of the risk, of the total risk, based on where it falls in the spectrum. So you could see that a risk that is catastrophic in its outcome and frequent is extremely high, has extremely high risk, whereas something that is negligible in its outcome and unlikely has extremely low risk. So you could think, well, we'll get to an example later on of a case of something that has high probability and high severity. So another way to assess risk or to provide it high, medium, or low ranking of the type of risk is by putting it on this matrix according to probability and impact. So this works largely similar to the composite risk management from the previous slide. It shows on a scale of 1 to 5 what the impact of the risk would be, just like the severity, and it shows what the probability of the risk would be from a scale of 1 to 5. Those that have low impact and low probability have a low overall risk, whereas those that have medium impact and medium probability have a medium risk, and then high risk for high impact and high probability. You can see that high risk has major disruption in the plan, medium has some disruption, and low has little or no disruption. So based on how you assess your risk will result in the mitigation techniques that you decide to use. There are 4 risk mitigation techniques. Obviously, you'd be a lot more prone to accept a risk if it was overall low threat to you, meaning that low probability and low severity. But accepting a risk is definitely not the preferred course of action when you have high probability and high severity. In those cases, you want to use some other mitigation technique, such as avoid, transfer, or reduce. Avoid the risk is what these individuals are doing. They're running away from the risks. They're going around it altogether, so they don't have to worry about it. Transferring the risk would be putting some other organization or some other element between you and that risk. Using this example in the literal sense, perhaps we could consider, if we had more time, building a device that would take this rock and transfer its kinetic energy away from falling directly on this trail to maybe falling off the side of the mountain, or maybe we put in a net over here which prevents the rock from falling altogether. That would be transferring the risk to something else. Reducing the risk, lots of examples for that. Reducing the risk, maybe you take a different path. In this example here, you could also say that reducing the risk would be some of those mitigation measures that I talked about with putting some physical constraint in here. And then accepting the risk would be these people just standing underneath it, waiting for the rock to fall on them. So those are the 4 risk mitigation techniques. It's important to understand what all the risks that are involved as we continue in our decision-making phase of the SDP. In order for a stakeholder to make the best decision, we'll give them the numbers. We'll tell them the overall value based on our value model. We'll tell them the overall cost and how it compares to value, but those really shouldn't be considered in isolation. We should always inject a risk analysis, identifying what the risks are, and then telling the stakeholders how we can mitigate those risks so that they can actually achieve the value in their alternatives. So here's an example for risk mitigation and risk management, and we use the example of a squad close quarters battle range, which is probably one of the most risky live fire exercises that you can do in the Army. The risk, of course, one of the risks is programmatic risk, which is fratricide. So you can't really control the environments. There are a lot of things that go into play, the human factors, etc. And it's not really technical risk. It's not cost risk. It's not a schedule risk. So it's something that is involved in the larger environment, and that is fratricide. So the probability of this occurring is relatively low, either a 1 or a 2, probably a 2, just because depending on the training of your squad. But the impact of it is extremely severe. If someone were to be shot by another soldier while on a range, that would have extremely high impact, both for the soldier, both of the soldiers involved, and of course all the other negative effects that would come. So that's why you can see the black dot has it right here, and it's a high initial risk. So moving forward, there's decisions on what to do with this risk, how to mitigate the risk. So a couple things that we thought of were to wear body armor, so that reduces the risk. You still have the same probability of it occurring, but the impact might be lessened by wearing body armor. Another thing you could do is to validate the squads, validate dry then live before they go into the actual live fire, or dry and then blank before they go into live fire. And that also reduces the risk. And possibly by doing that, we will reduce the probability of the risk. So you can see that as we add mitigation measures in place, we're moving along this spectrum in probability and in impact. And the last thing is target placement on single hot walls, another reduction technique that we can use. So in general, or in total, what we've done, and this is all a subjective assessment based on subject matter expertise and other factors and historical information, but in general what we've assessed is by mitigating through these measures, we can move the risk to a 4 on impact and a 1 on probability. We can make it very improbable of occurring, and that will give us a residual risk of medium. And this residual risk of medium we will accept because there's no other way that we can mitigate it further. We can keep searching for ways, but at some point we will have to accept some level of risk. And this is the case in most projects, in all projects. In the example that you're doing for your semester project is the case. There is going to be some risk that we're going to have to take. It's just a matter of understanding what that risk is, and the stakeholders truly understanding what they're getting into when they pick an alternative and the risk that is involved with that alternative. So that's half of the lesson for today, and now we're going to move on to sensitivity analysis. So the purpose of sensitivity analysis is to see if any of our assumptions that we've made in the project to this point will change the preferred solution. So we know, based on what we've done with value modeling and the additive value model, we know how to define the numerical best answer based on the values that our stakeholders identify. If you think back to what we did with swing weight matrices, we identified how the numerical value of importance for each value measure, we compared them to each other to determine what the global weights were, saying that my ideal solution will consist of all these values, but some of them are weighted more heavily than the others, but altogether they equal a whole ideal solution. So the sensitivity analysis that we do can be done, or the sensitivity analysis can be done in two ways. We can look at those value measures that we created and those weights that we've identified for each value measure, and we can change those and see how our alternative will change based on a fluctuation in the global weight or the swing weight that we assigned to it originally. This is a good technique to use when you have multiple stakeholders that don't have the same idea or the same opinion of the importance of certain values. Perhaps you have a stakeholder that thinks that value measure A is worth 50 on your swing weight, and then you have a stakeholder that thinks that value measure A is worth 90. Well, you can do a swing weight, or you can do a sensitivity analysis on this value measure to determine if either stakeholder, or determine if the winning solution will change based on stakeholder A's preference and stakeholder B's preference. This will help in decision making. And then the other way that you can do it is the other way you can do sensitivity analysis to determine if the decision is sensitive to changes in parameters. And this just means changing the inputs of your alternative, perhaps removing some value measures or value measures to assess, or even changing the parameters that compose your alternatives. We're not going to do this too much in this class. We're going to focus strictly on changing the value measure weights. So analyzing the sensitivity on the weights is another thing that must be done, because we know that there's going to be some deviation. We have to understand whether or not this deviation is meaningful. So what we do is we plot the weight versus the value for a range of interest, and we can see it. I'll just show you on the graph here. So this is for our soldier rifle squad of the future our value measure is soldier protection level. And this is a sensitivity analysis for soldier protection level. So we look at the range of swing weights from 0 to 100, 100 meaning that it is the most important value measure. The dotted line here indicates what our initial swing weight was. And we said that it was initially a 40. And with a score of 40, or a swing weight of 40, we identified that improved lethality alternative is the best alternative, this yellow line up here. And of course we always have the ideal, which will be 100 across the top throughout all swing weights 0 to 100. So by plotting our change by plotting the overall value, which is represented on the the y-axis, against the swing weight, we can see across the broad range of swing weights how the alternative changes. So at 40, our swing weight, at a swing weight of 40, our total value for improved lethality is about an 87. Now if we were to change that, let's go to the left and lower the swing weight. Let's say we change it to, we just move it down to 0. Then our overall value from a change of swing weight in soldier protection level of 40 to 0, we have a value of 81. So the total value goes down as we change the swing weight. If we look over here on the right side, if I were to change my swing weight from 40 to 100, then my total value of alternative improved lethality, the yellow line, would be roughly 90. So what we're looking at when we do these sensitivity analysis is we're looking at intersections in the winning solution. So the winning solution at our original swing weight is improved lethality, as I mentioned. And we're going to look at this entire graph and see if there's any case when the winning solution is not improved lethality, if there's a crossover. So we can identify a crossover right here at 80 swing weight. And at 80, what we're seeing is that the heavy squad alternative, the orange line, passes the yellow line, improved lethality, in overall value, which means that with a swing weight of 80 in the soldier protection level value measure, our winning solution would actually be heavy squad. That indicates that the value measure is sensitive. Because there's a crossover, because there's an intersection, our value measure is sensitive. But is it significantly sensitive? And that's when you see, that's when it's useful to look at this diagram right here. If we vary the weights for, or this text right here, if we vary the weights for protection level, the decision changes, but not within plus or minus 10%. So, and this is actually a typo which I'll change right now. It's sensitive, but not significantly sensitive. So it crosses over, the winning solution changes when we have a swing weight of 80 for soldier protection level, so we know that it's sensitive. But this change does not occur within plus or minus 10% of our original swing weight of 40. And the plus or minus 10% is indicated by the yellow box here. If this change were to occur, if the crossover were to occur within this yellow box, plus or minus 10%, then we would say that it is significantly sensitive. That our solution is very closely, our winning solution could very easily be another alternative based on a minor adjustment to the swing weights, based on a minor adjustment to stakeholder preferences. This is important for stakeholders to see because, especially if you have more than one stakeholder that is the decision authority, or if you have a committee of stakeholders or a number of clients that have differing opinions or views on things, it's important to show them that your winning solution can change based on a preference to a value or based on a score of the value that you give it. So when we pick value measures to conduct sensitivity analysis on, it's always important to first look at the ones that we have disagreement on. where there are some stakeholders that don't think that the multiple stakeholders that don't have the same opinion on their value. Another value measure to pick would be those that have extremely high values, so those that are in the 100 range for swing weight, and those that have extremely low values. The next video that you'll see posted is a tutorial on how to actually do this on Excel. I'll use the house picking problem again. I'm going to go ahead and get started on that right after this. Okay, I'll see you then.